Stainless steel is an alloy of iron and chromium. To make it, stainless steel must contain at least 10.5% chromium, which is giving it its corrosion resistant layer and used in many applications from cookware to car parts. This alloy is made by combining iron, carbon, and chromium till it melts together, and then it is tuned by removing its excess carbon by the use of a vacuum oxygen decarbolyzer and injecting an argon oxygen mix. Then once it has the right mixture content, it is cast into materials such as billets, slabs, rods, and tubes. It generally takes less amperage and less heat input to weld stainless steel because it is less conductive than carbon steel and aluminum. There are 5 grade families of stainless steel, which is ferritic, which is the more corrosion resistant grade and commonly part of the 400 series used in automotive applications and decorative trim. The next grade is magnetic but cannot be hardened by heat treatment. Next we have austenitic, which is non-magnetic stainless, part of the 200 and 300 series and has a high chromium and nickel content. Martensinic, which is also part of the 400 series, has similar properties to ferritic, but this one can be hardened through heat treatment. Duplex has 2 microstructures of both ferritic and austenitic, making it twice as strong while still being super corrosion resistant. Last, they have precipitation hardened stainless steels. This can be divided into 2 other families, martensinic and semi-austenitic, giving it high strength, and also can be hardened through the use of heat treatment. Here are some stainless steel grades and their recommended filler metal. 410 can be welded using ER410, ER308, or ER309. 316L can be welded with ER316 or 316L TIG rod, while 304 can be welded using 304L, which contains 5 to 10% ferrite to avoid cracking, while 321 can be welded with ER308L and 4030 with 308L, 310, and 309. Carbide precipitation is when chromium and carbon is attracted to each other and forms a granular layer of chromium carbides that weakens the structure of the weld and makes it more prone to cracking. The use of heat-resistant filler and post-weld heat treatment can help break up any of these carbides. Prolonged heating can also form these carbides. As well. You can tell when this occurs when the weld is gray or irregular corrosion has occurred. Stainless passive fission is a process that makes it unreactive to moisture and oxygen by creating a layer of chromium oxide using acid bath similar to aluminum anodizing. Usually this type of stainless is used for moving parts for machining and grinding operation, as this reduces wear and tear, extending the life of the part. As you can see in the diagram below, it shows you how the chromium and oxygen react with each other, forming a chromium oxide layer to protect against corrosion. Weld pickling is needed when the weld zone develops a heat affected zone and scale on its surface, and the use of paste and helps remove the scaling and rapidly develop a chromium oxide layer to protect the weld from corrosion. Pickling gel is painted on with a brush on the weld area. Both passive fission and pickling improve corrosion resistance. Pickling will etch and make the weld dull, while passive fission won't affect appearance at all. Here's a short video on the passivation process.